So here's a secondary example of being able to compute the sample standard deviation given a list of ungrouped data. So we have this list of data, 0, 1, 0, 0, 1, 1 to 100. Now clearly if you look at this data, 100 is an outlier. So you would expect, since there's an outlier, that we might have a high standard deviation. And another thing that kind of tells us that we might have a little bit of a high outlier is that the range, which is 100 minus 0, is pretty high as well compared to all the other observations. All right, so these are just things to kind of think about, right? So when we do this, the first thing you probably should have done is, if you practice this, first thing you're going to do is compute x bar. Well, first you're going to find the sample size. In this case, the sample size is 1, 2, 3, 4, 5, 6. And then from there, you can go through and figure out what the mean is. All right, so remember to find x bar. That's going to be equal to 0 plus 0 plus 1 plus 2. There's another 1 in there. Plus 100 divided by 6. And we can add this up really easily. That's 104 over 6. And if we go to our calculator and just throw that in really quickly, 104 divided by 6, I think that's 17.33333. Yep, 17 and a third repeating. All right. So now we have our sample mean. To continue to compute the sample standard deviation, we need two columns. So first we need x sub I minus x bar. So that means we're going to take each of the observations, 0, 0, 1, 1, 2, and 100. And from that, we're going to subtract that 17.333. So just give me a moment. And we're just going to do that in our calculator. And at this point, you should be pretty good about subtracting. So we're going to get negative 17.333, negative 17.333, and then we're going to get negative 16.333, and then we're going to get negative 15.333. And then finally, when we subtract up the 100, that should be 82.667. Right? Just to verify, I'm going to flip that over. And 82.667 is correct. All right. Now, you might recall, after you go through, and we have to go through and we have to square each of those numbers. So we're going to say x sub I minus x bar squared. All right. And so we're going to square each of the numbers. Now, don't forget, whenever you square a negative number, it becomes positive. So when we throw it in there, we're going to do quantity negative 17.333, and we're going to square it. All right? And that gives us 300.433. And then we can just go right down the line and square each of the numbers. And so I did this on a separate Excel sheet, so we can just kind of get through it. So when we square each of these numbers, that's going to be, like we said, 300.434, or 433, excuse me. And then this one, when we square it, it's going to be the same thing. And when we square the 16, 266.767. And then with the 15, 235, 101. And then finally, this big one squared, 6,833.833. Right? And then the last thing we have to do before we start using the formula is we have to add these up. Right? So remember, this is the sum of all x sub I minus x bar squared when we add this up. And when we add that up, that should be 8,203.333. Approximately. Okay, so you might get a little bit different number depending upon how you rounded and that sort of stuff. All right, so hopefully you got that far. If not, make sure you understand or ask me some questions as to where you might not have gotten it. Our sample standard deviation S is going to be equal to the 8,203.333, and we're going to divide that by 5. And the question you might ask me is, why 5? Well, remember, in the denominator, it's n minus 1, which is 6 minus 1, which is our 5. To finish this off, we're going to go through our calculator, and we are going to say second x squared to get the square root, 8203, excuse me, 0.333 divided by 5 under the square root. We're going to hit enter, and we get 40.505. All right, so, and that's kind of what we expected, because remember at the beginning of the problem, we said that the data was really spread out. So we should have a high standard deviation, as opposed to the previous problem where we had a lower standard deviation. Okay, so this ended up being 40.505. All right. So hopefully that helps you to be able to understand how to get to the sample standard deviation. Now, before we finish this video, I do want to show you how to use your graphing calculator to check your answers. All right. Now, on the quizzes and on the examinations, I will expect you to go through and illustrate step by step how you did it. However, the graphing calculator, as some of you might know, can do a lot of these functions. So I do want to illustrate how you're going to do that. All right. So I'm going to clear all this stuff out, kind of start anew. The first thing you're going to do is you're going to enter the data into a list. Right? To do that, you're going to hit this stat button, and you're going to hit enter for edit. All right, now let's say there's some jargon in there. So somebody just put a bunch of stuff in there. To clear out any list, what you're going to do is you're going to highlight that list, you're going to hit clear, and then you're going to hit enter. And that'll clear out any list, any data that you have in there. Now remember the data we had. We had 0, so hit 0, enter, 0, 1, 1, 2, and 100. So each time we're hitting enter to signify that we have a new entry or a new observation. Okay. Now once you have all the data in there, what you're going to do is you're going to hit stat, or you're going to quit out of here. So second quit. You're going to hit stat. You're going to go over to calc and see where it says 1var stats. You're going to hit enter. The list should be in L1. If you have a TI-83, you might not even have to do this, but just hit enter a few times, making sure that your list was in L1. Right? And then you're going to calculate, and I'm going to show you a few things that this does. Right? So one thing it does is it gives you the sample mean right away. Remember, we got 17.333. Right here, S sub x, that gives you 40.505. That number may or may not be familiar to you. Hopefully it's familiar. Oh, we got 40.505 right here for the sample standard deviation. Now, fortunately for us, the calculator does it really quickly. But now we know how the calculator does it. And that's why we're in honor statistics, because we want to know why things are and how we get there. Obviously, n equals 6, we can count that. But scroll down a little bit more by hitting this down arrow. Notice right here, we have min, Q1, median, Q3, max. Where have we seen that before? Well, that's the 5-number summary. So now what you're noticing is a lot of the things that we're doing by hand, you can also utilize the calculator to be able to compute. Okay, so again, I will expect you to be able to know how to do these things by hand. However, on a quiz or examination, it might be helpful for you to be able to check your answers. Okay, so hopefully that helps you to be able to solve for standard deviation for a sample of ungrouped data, and then also to be able to utilize the calculator as to how to check your solutions. In the next video, what we're going to do is we're going to look and see what happens if the data is grouped. All right.